Our next speaker in agenda, Stanislav Grichkosey, platform software engineer at Grammarly. Stanislav is a platform engineer and bring over 15 years of experience in information technology, primarily focusing on cloud infrastructure. As a platform engineer, he is passionate about sharing his experience on building scalable and secure cloud solutions with the best practices and providing comprehensive guidelines in various areas such as network, Linux, AWS, internal operations, and many more. Stanislav will present the topic scaling AWS infrastructure, and please share your questions to Stanislav. And the best question will get the AWS credits and special prize from NX. So, Stanislav, stage is yours. Please welcome.
Hello, dear everyone.
Hello.
All right, thank you very much. Dear everyone, hello. My name is Stas, and during the last 4 years, I am leading cloud infrastructure at Grammarly. Today we will talk about challenges Grammarly faced during our attempts to scale infrastructure and how we added more regions. So I started my career like 20 years ago as a system administrator in internet service provider called AAP. Since then, I worked with a lot of great people in the company listed below. And fun fact, I had to use Web Archive to retrieve some logos for the slides. Let's begin. We'll cover the following topics today. Requirements, why we ever started to change anything. What we had at the beginning and of the restructure and of the reorganization. We'll talk about environments and multi-region network connectivity. We'll describe why backwards compatibility is crucial for us and see the final state, which is in production for at least 2 years now. So requirements. We agreed to build our new infrastructure around 3 pivots. Compliance to security standards, keep our you build it, you run it culture, and trying to keep amount of complexity of infrastructure operations low. In order to successfully pass various security compliance audits like SOC 2, ISO, HIPAA, CSA, we have to separate environments and isolate administrative and network access in between them. In addition to audit simplification, we'll reduce blast radius of attacks of operation mistakes and will lower visibility and discoverability of potentially vulnerable services. Our culture, you build it, you run it, require clear ownership of service billing and operations. And of course, infrastructure operations themselves must be simple. For example, we do not have capacity to tune more than 2500 IAM permissions. And that's the amount from 5 years ago, 2017. And hitting account-specific limits by one service must not affect another service. Another example, if imagine your service team have to scale your Fargate service and launch 50 additional tasks. AWS API throttles run task call down to 1 per second with a burst of 10 calls, meaning from 50 required additional tasks, you get 10 and then 40 seconds wait for others. And just imagine if another Fargate service within the same account need to scale too, because they dependent from your service. So throttle limits per account, so you are getting a high chance to fall into cascade failure. So almost 3 years ago, when we started working on a new infrastructure, we had the following. Grammarly production services were presented in North Virginia in 3 availability zones out of 6. we dedicated AWS account per team, and each account had a single VPC, which was used for all the services of particular environment. We tried to secure everything using security groups and used VPC peering to create cross VPC connectivity. All accounts were universal. Engineers could perform any operations on any service once they get into account. It doesn't sound complicated, and you can easily imagine such a structure and manage it. But once you draw the scheme, you gotta get some questions from compliance and business teams. So on the picture, small boxes are AWS accounts and VPCs within them, and arrows are VPC peerings. So when one of many services from one box want a connectivity to another account, to another box, we basically merged two networks, and security groups were the only way to stop traffic between services which are not supposed to communicate with each other. So reasonable questions like, can we isolate one service from another and make sure it stays isolated? Or can we scale this scheme 10 times? Well, scaling gonna be difficult knowing AWS hard limits of 125 peerings per VPC. But even if we could try to add one more region into the schema, so something had to be done, and we started from environments. We decided to follow least privileges principle, meaning everything should be isolated unless the particular access has been provided via systems with appropriate login that can be audited. Estimated capacity of our team didn't allow us to micromanage permissions on IAM level. Also, teams in Grammarly become more ephemeral, and one engineer could contribute into many projects which belong to various teams. And in previous state, we were forced to provide excessive privileges to adjacent services within the same account. Having all this, we decided to dedicate AWS account per product per environment. In this way, we'll get most flexible scheme to administratively isolate environments and resources, but still providing the full access to service owner, which saves our you build it, you run it culture. And by avoiding permissions micromanagement, we allowed service teams to move fast in terms of allocating required AWS resources and services. As a side effect, we've got a possibility to easily manage environments using SCPs in AWS organization units. Looking good, but what to do with network latency for traffic-intensive, tightly coupled services, which still belong to different teams, thus reside in different accounts. VPC peering do not add additional latency, but we've seen scaling limits with it, and transit gateways add additional hop into the road. Going through all the possible connectivity options in AWS, we've decided to centralize VPC management in separate accounts and share particular VPCs to target servers accounts. Meaning, in some cases, we have AWS accounts without VPC at all. And if we need lowest possible latency between services in different AWS accounts, we simply share VPC between them. Administrative access to services stay isolated. At the same time, they share the same network. It doesn't look difficult to implement until you actually start implementing it. Account provisioning. Our manual procedure required 2 days of work to create one AWS account and services in it. Don't think we never heard about infrastructure as code. It It's just about the complexity of additional services within an account. So today's and obviously we wouldn't survive with such provisioning procedure in the new scheme, and that's why we created a new tool. We call it Platformer, and provisioning time reduced to 2 hours, and we are still improving and automating it, and we'll share details in future meetups. Another issue we faced is defining a service or a group of services or a product. It's not always clear what exactly is a service and how to group such services. We don't really want to create an account with 30 additional AWS services required for audits and all this just to launch Lambda. Or do we need to create it now? We've defined the criteria for ourselves, but we still have some cases where it's a rule of thumb, and yeah, sometimes we don't know if we really need a new account. Data processing services do not tolerate additional latency in any manner. Some of such services respond in less than a millisecond. So it was crucial to separate VPCs from accounts to get more flexibility in network connections. Granular access allocation required us to define precisely cross service connectivity. And legacy peerings created years ago didn't answer a question if service A is actually allowed to communicate with service B, because we had multiple services within the same account and connectivity set before was redundant, so we had to work that out almost from scratch, of course following the least privileges principle. So out of all the network connectivity options, transit gateways looked for us the most flexible and scalable way to connect VPCs. There are almost no alternatives, and if you do everything right, transit gateways looks really decent. Within the single region, you just need to create it and attach VPCs. And if you need more than one regions, you have to take care about route summarization or route aggregation, the ability to use single route to target particular region. If every of your regions stay within a single block or of IP addresses or within a set of block of IP addresses, you will avoid routes micromanagement. In this way, in order for a packet from VPC A region A to get into VPC B region B, you don't need to state in a TGV transit gateway of region A route to VPC B. It will be set already as a cross-region route, which you set just once upon configuration or creation transit gateway. And let me talk a few more minutes about default and dedicated route tables in transit gateways. There is a difference between them. In dedicated mode, transit gateway creates a route table per VPC attachment. And this route table is responsible for traffic coming in or out of particular VPC. A part of such tables, we have to manage dedicated route tables to transit gateway itself to route traffic coming from another transit gateways or from external connections. So there are a few places where you have to manage your routes. It's subnet route table, dedicated to VPC route table, and dedicated to transit gateway route table. And the same in backwards direction if you don't use UDP, if you need actually backwards traffic to flow into. Managing this as a code is not trivial, but possible. We proof of concepted it in Terraform. So dedicated tables allow you to specifically define traffic flow. In contrast to dedicated, there are default route tables, and everything is much more simple with it. All the routes to all the VPC attachments, as well as to transit gateway itself, reside in one default route table. Why is this simplification is not always good? If you are not using ACLs or security groups to filter your traffic flow, once traffic gets into the transit gateway, there is nothing that can stop it from reaching a target destination, because default route tables know everything about everyone. So transit gateway will simply route traffic to a particular target, and default route tables are much more simple in management, but it requires attention in other security measures. In cases when additional transit gateway hop is not appropriate and latency requirements are strict and critical, we've decided to use shared VPC, which we share to all AWS accounts with tightly coupled and traffic-intensive services. As a result, traffic-intensive services are administratively isolated one from another, allowing service owners to keep full access within their account. But the VPC is shared for all. But the VPC shared for all, so they can reach each other without additional latency or hops, basically staying within the same network segment. It also helps to reduce traffic costs and simplify VPC operations at scale. All right, almost there, folks. Hopefully you still follow. Remember full mesh on VPC peerings. On this scheme, on the left side, you see the legacy infrastructure. And on the right side, we can see three isolated one from another environments. One of them production, others lower environments. And VPC is connected through transit gateways, one to each other, and transit gateways are connected to each other using transit gateway attachments and form full mesh for cross-region connectivity. So we have to get rid of the left part, meaning migrating all the services to the new VPCs in new accounts, or integrate all VPCs into the new infrastructure. But it's also not that simple because of IP route segregations, multi-region, and blocks of IP addresses. So there is also IP addressing, all IP addresses, new IP addresses, and we have to integrate one into another because we cannot instantly migrate all the services and need working connectivities between new and old infrastructure during the transition period. And let me dive a bit more into IP addressing. It's low-level details, but we still would like to share. Historically, on the left part, we cut 10/8 on /18 blocks and dedicated /18 to each VPCs. Having relatively small amount of VPCs in old infrastructure, we've got 10.64 up to 10.255 free. That's 3 blocks of /10. But whatever we tried to do with these 3 blocks, we couldn't fill them into 3 environments and 5 regions. And we haven't even considered other clouds yet. After going through lots of options, we decided to add completely new block, 100.64/10 into our infrastructure and use it for lower environments only. Even so, this block is dedicated to carrier grade NAT or NAT 444 according to RFC. It is safe to use it for internal networks, and AWS mentioned it in their documentations too. It appeared to be a very convenient solution for us. We can precisely tell from the first glance if there is traffic flow between production and non-production environments. It also simplifies configuration review and merge requests. So such aggregation made new infrastructure backwards compatible. So traffic can flow in one or another direction. And this allowed us to reduce migration stress. Instead of turning off a group of cross-dependent service from the left side for maintenance and move it to the right side, we can now partially migrate them one by one and create temporary connection between old and new VPCs by attaching them to transit gateways. It might look like operation headache, but we avoided a complete nightmare this way. And as mentioned before, we decided to completely detach VPCs from AWS accounts. So new accounts we create without VPCs at all. Depending from the service need, we create a required VPC in our network management account and share this VPC to a target service account. Or if there are strict latency requirements to other services, meaning to other dependent services dependent from each other, we just share VPC with required service to particular account. And different services require different amount of IP addresses. And even though we have enough of IPs for today, it's still finite. So we decided to make VPC sizes dynamic, meaning if service require CloudFront, S3, and few lambdas, we can avoid wasting /16 on it and provide /22. And vice versa, if we plan to host 1,000 of instances of few services within a single VPC, we can dedicate appropriate block to it. And ability to add more than one block to a single VPC allow us to not stress on estimates upon creation. We can always add more. So over 2 years have passed since we released our new infrastructure. And here's what we have as of today. We can deploy our product to at least 5 regions, 5 AWS regions. We use all availability zones in every region we deploy our service to. This helps to reduce a lot of stress, like particular instance type availability or unavailability, or avoid network convergence when private link from one zone in one account couldn't connect to another zone in another account, because zones are different but aliases are similar. Projects and services are isolated in particular environment in a particular account. AWS account is not tied to AWS VPC anymore. Service or a project stay isolated until someone specifically allow administrative access or network connectivity, no peering smash anymore, and stressless migration to the new infrastructure. And everything you heard about today wouldn't have been possible without the team of highly qualified professionals. These guys contributed a lot into this project, and I feel really proud being part of such team. And if you noticed any inefficiency, or you know how to improve it and how to improve it or scale it, join us. And I really appreciate everyone helping Ukraine to survive in this war. Thank you. Thank you very much.
Thank you. Thank you, Stanislav. It's really great presentation. We have a few questions. So the first one from my side, you have a huge infrastructure, right? Deployment view and you demonstrate the production environment and other ends. So how how often you release new version of the product? So how this process looks like? Is it, do you have some manual work during this rollout? So could you please share a little bit more
Uh,
here?
yeah, sure. It's a great question, and the answer is our culture. As I mentioned, is you build it, you own it. Meaning, we have a lot of separate teams who own whatever they do, and there is no like dictatorship or no strict rules, no common software development life cycle for the whole company, which everyone requires to follow. So it's up to service teams. Our goal as a platform is to provide tools to for them to use everything, and these tools might be easy to use and flexible. So of course we still have compliance. We still have to follow to be compliant with security standards. We have to update our AMIs, and that's what we do. That's what platform team do quarterly now, and we are looking for increase the frequency of these updates.
Hmm.
Hopefully, I answered.
Yeah, it looks like you have standard microservice architecture where each team responsible for their part of the product, right? And they release when they are ready, right? Hmm.
Yeah, yeah.
That's
No
awesome.
dependency, and yeah, it's really flexible. And we have a lot of different time zones now, and we do not feel a need to even synchronize. Everything is work like a separate service, and it's working autonomously.
Hmm. So we have a lot of questions actually. Let's try to cover some
Thank
of
you.
them.
Thank
The,
you,
the,
everyone.
the, yeah, it is a really great topic and knowledge sharing. Yeah, session. So the first one, probably easiest one. Which AWS certification exam was the hardest for you? So what the most complicated exam for you from AWS, if you passed any before?
Guys, I have to apologize. To my I haven't passed any really.
Did you prepare for some? I don't know, maybe
Uh,
some DevOps or data? No.
no, not the latest one I was prepared to was Cisco CCNP, and I honestly couldn't get to the result because of different circumstances. But that was the hardest one, but it was like 10 years ago, and since then I don't remember myself preparing to certifications. Sorry for that.
Yeah. So practice, practice, and practice, right? Yeah.
Kind of. No,
That.
no. I read a lot about fundamentals. I read a lot about how things work under the hood, and whatever. Whenever we're trying to implement something, like in this case, transit gateway, we had a lot of discussions with AWS support about what is this, how does it work, how does it scale, do we fall into some kind of issues because it's actually AWS managed service. And honestly, we found some issues which AWS fixed before, but it was good to know that there were actually issues, scaling issues with AWS, and
Mhm.
Slack had outage because of it. Of it, it was good to know.
Mhm. Yeah. So in this case, you're using some business or enterprise subscription, right? If you can
Yeah,
use
yeah, we have
the.
enterprise support, and yeah, we really appreciate network architects from AWS. In particular, Tom Adamski helped us a lot in with validations of this infrastructure. They even visited us in Kiev before the launch itself, and we spent like 3 days going through all the schemes, looking for the bottlenecks and solving all the difficulties I mentioned. It was attention, a bit of
Mhm.
tension work.
Nice, nice service from AWS. The
Yeah.
next question: how do you manage overloads? I I I think in regions.
Well, we honestly do not experience any network or infrastructure overloads yet, because uh, transit gateways themselves are they are scaling just like load balancers. You can imagine a load balancer, application load balancer, network load balancer, whatever. They just add horizontally nodes or vertically whatever it needs. So transit gateways are routers, and they basically add more instances of such routes once we need once we require more traffic to flow, and that's I don't honestly have even metric to tell how much we use now because it's all under the AWS hood, and
Mm-hmm.
everything else. If you mean the services overload, we scale them horizontally most of the
Mm-hmm.
time, and I don't remember trying like scaling vertically unless we prepared for some big event. It happened, so we just changed instance type to make sure we have enough vertical capacity too. But that's what service owners handle, and they are experienced enough to not fall into cascading failures whenever we have this health check failure, which causing the whole cluster to go down. We know about the things. We are ready, and we basically scale whenever we need or optimize a code or solutions which we run to be more efficient.
Maybe you run some just the sub question to this. Maybe you perform some load or stress testing before
Yeah,
some releases.
sure. Yeah, we have like every system. Our system also have bottlenecks. I think I can talk about one of them. This our Artifactory storage, with all the Docker images, with all the artifacts required to launch applications. So that's basically a cluster. Which required for our service to launch. So if this cluster goes down, and we've got a load spike, we not only
Mm-hmm.
cannot handle a new traffic, the existing service get overload and gets taken out by health checks or by any kind of transit of target groups activity, and they get out. So we are again failing in a cascade mode, which is bad. So yeah, we are trying for such systems to perform load tests, and we do it hard. So we just trying to keep them to handle abnormal amount of traffic. We don't expect that amount in traffic any day during the next 10 years, but still we for such systems we are trying to be ready for unexpected to get basically 90% of node down, and we still have to survive because everything else will
Mm-hmm.
fail if we fail.
Mm-hmm.
So
All
yeah, we do
right.
test.
Yeah, okay. Yeah. Do you plan to create a multi-cloud platform?
Yeah, we not that we are planning, but once we see an opportunity, I mean AWS is doing a great job for us. We are really happy with the services, and of course outages happen. That's why we are getting into the multi-region, and but overall services themselves are sufficient for us, and until we see a need to use more efficient service in GCP or in Azure, we are going to do this. And we are exploring some machine learning services from GCP right now, but not that we are expecting to launch product itself in GCP. We might use it for some particular purposes. But whenever we build anything, we think about multi-cloud too.
Mm-hmm. All right. So right now the strategy is vendor lock with AWS.
Yeah, we did it a long time ago.
Okay, yeah. The next question: how do you test routing configuration?
Yeah, sure. We have a QA environment which is consistent to pre-prod environment, which is consistent to production environment. So we have three separate environments, and before we apply any change to production, we apply them to QA, validate, wait for I don't know, someone scream, and then we apply this to pre-production and see if anything happens, and only then it gets to production. So it's all it's all a flow to production, which we are trying to follow to avoid any kind of issues.
Mm-hmm.
Uh,
So
we also use AWS Network Manager. They have a great tool to see if packet from VPC A can actually reach a packet to VPC B in whatever region. So we use this too. Really
yeah.
convenient.
Actually, next question regarding VPC IPAM for IP management. So, do you use this service from AWS, and is it reasonable in general?
Which service? Sorry, I couldn't get it.
IPAM for IP management. In VPC, they have
Mhm.
manager tool for managing all your IP pools, etc. Do you use
Mm-hmm,
something?
mm-hmm. No, we do not use it, and yeah, we we tried to build the infrastructure the way to not overcomplicate IP management. Having these different blocks of IP addresses defined per region and
Mm-hmm.
following this scheme allow us to not even think about IP addressing a lot. We automated VPC creation, and our tools create a free block of required VPC size from a pool. But the pool itself is like a block of IP addresses, and we have a configuration which basically states which VPC has which IP block, and our tool define which the next block is free, and it's so we don't feel a need yet to visualize what IPs were, and
Mm-hmm.
all we care is we have enough of free blocks yet, and we have reserve blocks, and honestly, we don't feel a need to manage IPs on this level on this, yet, at least yet. And we have
Okay.
different blocks for lower environments, which we don't care much. Which I mentioned is it is 100.64, and we allocate them like whatever because it's not production. And we whenever we work with production, we are more careful, but still we don't feel a need to use API management tools yet.
Mhm. All right. All right. The next one: did you try embarrassing more event-driven architecture approach? For example, using event bridge for cross-account events. This could potentially solve a lot of direct dependencies between your services. I don't know
Uh,
this event bridge service, so
well, yeah, I have to check, guys. Sorry, I haven't used it before. Thank you for pointing it. We will check. Thank you.
that's probably will be one of the question which you will choose as the best one.
Probably everything
Yeah. Okay.
used. Yeah, it's great. It's great to get everything.
Uh-huh. You mentioned that for infrastructure as code, you're creating some tool platformed. Why did
Mhm.
you decide to create your own tool? What did you achieve using your tool comparing with Terraform or other uh, infrastructure as
Yeah.
code?
Thank you. Great question, actually. Uh, yeah, we we use all of them. So there are things which we could do using Terraform. We are generating out of templates a code to create an account, which describes what we need in a particular account. Due to a number of compliances, we have a set of services which we deploy by default upon creation. They are security related or audit related, etc. So whatever we could describe with AWS with Terraform code, we describe it and we basically apply. But the tricky thing is applying a code. There are like a need to subscribe for enterprise support, and you have to create an API call for this, and there is no Terraform code. There were at least no Terraform code to cover it. And the same for a set of different services. Terraform code just doesn't support it yet, or doesn't support it properly, and or the way we have to apply is different. So we have to create an account, submit a ticket to security to validate something, or create anything. So it's not about a code, it's about a flow. And in Terraform, it's quite difficult to define a flow for creation. And of course, we are trying to automate. So whenever Ukraine is sleeping, US still could create an account and work without us. So this automation also requires flexibility, which Terraform just doesn't provide. It doesn't mean we don't use Terraform. We do use Terraform, but in addition to Terraform, we have this platformer tool. We have other tools too. Yeah, that simplifies automation, and we still can manage it. There also are open source tools. We tried them. For some reasons, they couldn't fit to our particular process. It's about us, not about tools.
All right. Probably last question. Do you use what are you using for running services? So ECS or EKS for Gate, for example, and for serverless, do you use Lambda or any other serverless
Yeah,
services?
love this question. Thank you very much. It's the one we tried to solve like 4 or even more years ago when I joined the Grammarly. We tried to figure out which service orchestrator would fit best for Grammarly, because we had a custom solution which was created even before autoscaling group existed. So it created a group of of instances to it mimicked actually autoscaling group logic. It's really great, but within the autoscaling there was no need to keep supporting it. So we decided to switch to a new orchestrator, and the team capacity wasn't good enough to manage Kubernetes as a service, meaning in-home Kubernetes on-premise. And EKS was in public beta 4 years ago, and it wasn't really good. But we still tried to consider it. It wasn't working for us good. So the only option was ECS because of enterprise support, because of a lot of documentations, and because it just working. Right now we are facing consequences of such decisions. We couldn't make blue-green easily. We couldn't make canary. We are facing consequences. Still, we think it was good decision by that time. Right now, we might switch to something else, and we are getting ready for another project. Please join us.
Nice offer. So thank you. We're out of time. Thank you, Stanislav. And guys, we will have 5 minute break. See you in 5 minutes. And please make your donation and support freedom in Ukraine. You could find the QR code and the charity tab on the left sidebar. Thank you again, and see you on the next.
Thank you, Dmitros. Thank you, everyone. Appreciate all the questions. Bye bye.